All right. Share screen. All right. Great. Hello, everybody. Thank you so much for joining our office hours today. My name is Tanya Hack. I am the Senior Director of Programs at Games for Change, and I'm also joined by Alex Fleming from Mouse, who you will be hearing from shortly. So welcome. Before we get started, I wanted to ask everybody to do a couple of things. Number one, if you could please complete a super short survey, which you can access at the bit.ly link shared here, G4C/survey. My colleague Marissa is also going to enter that link into the chat box of the YouTube Live chat stream so that you can just click on it there. And then the second thing is access a Google Drive folder which contains helpful materials and handouts that we will be referencing throughout this session, and which you can also go back to after the session as you are working on your games and submitting them to the competition. So both of those URLs should be in your chat stream. Our agenda here is a very brief welcome and introduction, which we're going through right now. I'm then going to turn it over to Alex from Mouse, who is going to provide about 20 minutes of instruction addressing questions that you all have submitted relating to Scratch. From there, I'm going to take back over and I'm going to run through the process of how to submit your game to the Student Challenge competition. And I should be able to do that in about 5 to 7 minutes. I gave myself 10. And then we will leave the last half an hour really for a live Q&A. And in order to ask questions, you can enter them through the survey link that we just shared, or you can enter them into the chat stream once we get to, I mean, really throughout the meeting, but once we get to that piece of the session. And then before we get fully started, I just wanted to run through a couple of housekeeping items and some expectations. Please be respectful, kind, and responsible as you're using the chat functionality. We are moderating it, and we have a couple of colleagues who are kind of overseeing the chat stream. So, you know, if you suddenly don't have access to the chat stream, it is probably because you have entered content that we felt was questionable. We will then put you on a timeout and let you back into the chat stream. But just be careful about what you're typing, and again, be kind, be responsible, be respectful. And then finally, just wanted to mention that there's a 15-second delay in this stream. So if you feel like your computer is lagging or there's a level of disconnect between what Alex and I are saying and what's being typed in the chat stream, it's probably because of that delay and not because your computer is actually lagging. So with that, I'm going to stop sharing my screen and I'm going to hand it over to Alex.
Thanks so much, Tanya. So yeah, my name is Alex. I work with Mouse. We're always thrilled to partner with Games for Change for this student challenge. And I'm going to be doing a little game dev tutorial today, going over a simple Scratch game using a lot of concepts from the questions that we received. Oh, I should be sharing my screen, so let me do that. All right, let me full screen this. So today I'm going to be running through how to make a simple game with collecting. And I'm going to be using as a basis for this game a game that was created as part of the Scratch Creative Computing curriculum from Harvard originally. That is, I think, one of the best introductions to variables as a scoreboard mechanic. So I saw some questions about how to use variables and what the difference between them and broadcast blocks are. And I think one of the simplest ways to use variables is as a score or a high score. Many of you who play games should be familiar with a mechanic like this. I do want to show where I got this from. There's this great project called Extensions that's part of the Creative Computing course that's in the handouts folder with all the other documents that are reviewing some of the stuff we're going to be going over today. Whoops, I've lost. There we go. But I'm just going to be remixing the score project here at the top. For some reason, it wouldn't let me click there, so I've got the link here. So I'm going to open up a Scratch project. I'm already signed into Scratch here. This project has these two really important blocks. There's when the green flag is clicked, we're going to set our score variable to 0. That's at the beginning of our game. And then every time we click on our sprite, it's going to change score by 10. A variable is just a value that changes. Like a score, it can be at 0, it can be at a high score later at a higher number. Can really be anything. So this is really the simplest application of a score. And in order to see what's going on here, I just got to enable our variable by clicking on it on the left. So now if I click on the cat, you can see our score goes up. Awesome. So that's a start with variables. The next thing I want to do to make variables a little bit more complicated is to use a variable to track the velocity of our character. And for this, I've been having some fun with this. I'm going to pick a new character instead of the cat. I like this crab. Let's be a crab instead. I'm going to quickly copy over our code into the crab and delete the cat. So here's our code. So now I want to be able to move this character. And this is going to take me to the second part of my demo today, which is velocity. So this is a really simple script. I got this from the Scratch wiki. And this script is the physics for velocity. So we're going to create this when the green flag is clicked. We're going to be forever looping through checking to see if the left arrow key is pressed. And we're going to change our velocity variable, either reducing it or increasing it, depending on whether or not we're pressing the left or right arrow key. Then we're going to reduce our velocity just over time. If you've played Mario, many people are familiar with this game. You may notice that when you let go of the left or right mouse button, or the left or right buttons, that Mario kind of glides to a stop. So this is done through that same thing. And then finally, we're going to actually move it. So I'm jumping into Scratch here to start building this. So we need, when the green flag is clicked, a forever loop, and then we need 2 ifs, because we need to check for our left and right arrow keys. Oops, that's an if else. Okay, so we've got 2 ifs. We need to sense, that's the wrong sensing block. If a key is pressed, we want the left arrow key, and then we need the right arrow key. Yeah. We need a variable. This is really important. We're going to make our next variable here. So this is going to be our x velocity. And the reason that I'm making an x velocity and not just a velocity variable here is because we're gonna be tracking how our crab moves both left and right, which is the x axis in Scratch, but also vertically. We want to be able to move our character in 4 directions. So We're going to have a variable to track how quickly and in which direction it's moving horizontally, and one for vertically as well. And actually, I'm going to add a backdrop here because I think it's helpful, which is this XY grid backdrop. So we can actually see the XY grid of Scratch here. So if you're not familiar with this, Scratch, your stage uses this coordinate plane, uses minus 240x here at the left and 240x at the right as a way to be able to track what's on your screen. So I'm getting away from myself here. So let's add in our variable change script. I'm going to go change x velocity by 1 if we hit the right arrow, and we want to change our x velocity. We want to reduce it because moving to the left is moving in a negative direction on this grid. The center is 0, 0 here. We've got left and right arrows. Now we just need 2 more things. We need to set our x velocity to an operator. We're going to multiply something. With a lot of game programming patterns and designs, you'll find the numbers between 0 and 1, those decimals, can be really useful for doing all sorts of different things with games. So we're going to multiply, our x velocity by 0.9 because we want to make it reduce regardless of whether or not it's positive or negative. It's just, we want it to get smaller over time. That's the friction of the air. We just don't want it so that when we press left, our character is going to fly off the left side of the screen forever. Then we're going to finally go to the motion block. And we're going to change our x by our x velocity. Now, if this is going a little fast for you, if this is confusing, I'll include the link to be able to remix this during the question and answer section. You don't have to understand exactly how everything works as long as you can identify that this kind of script is a velocity script, and you can copy and paste it and kind of retool it. The next thing I'm going to do here is test it. So I'm going to hit the green flag to get this to work. You can see we have an x velocity value here. And hey, look at that. We're moving now. I'm just going to really quickly duplicate this. Duplicate this whole thing. I don't need all of it, but I'd like some of it. Because now I want to do this with our y velocity. I'm going to create a new variable. I'm going to change this now. So I want 2 more if statements. We're going to be checking not only for our left and right arrows, but now we want to check for up and down. So up arrow, down arrow, and we're going to change this to y velocity. And if we hit up, we want our y velocity to go up. We want to move up. That's a positive direction. If we go down, that's a negative direction. So making that -1. And I can just drop this into my big forever loop that has all of my code that checks to see if I'm pressing buttons. Then I need to also add in this code here that's going to reduce my y velocity over time. I'm going to replace x velocity, y velocity. Drop that right in there. And then this one, I got to get a new block, actually, because I don't want to change the x position twice. I want to change the x and the y of our player here. So I'm getting change y by. Now I got to go back to variables, grab y velocity. And now we've got this big, chunky thing. I'm going to leave a comment here that this is our velocity code. But now, I don't know if you can see that icon. Now, if I move my crab back, I can, yes, press up and down and move the crab freely. So we've taken variables. We've made a really simple score right now. I can click on them to get my score. But I want to make a game where you collect something to get a score. That's I think a really common game type, and you can do a lot of different variations on that collecting mechanic. Um, so let's make some collectibles really quickly. I'm going to create a sprite. I think foods make a lot of sense. They're used in a lot of games as collectibles because you eat them, you use them up. So let's make this be, you know what, cake is fun. Let's make this a lobster that wants cake. Sorry, a crab. Actually, to make this a little less confusing for me as a game developer here, I'm going to rename the crab to player, just so I know that that's the character that the player's moving. This cake here, I want to make it collectible, so it probably should be smaller than my character. I'm going to change the size here from 100 down to 50. That's pretty good, but I think it could actually be even smaller. I'm going to make it 30, and I'm going to make my player even smaller. I'm going to make my player like 60. And let's make the cake 20. Yeah, there we go. Now there's a lot of room on my screen for me to be able to run around and get this cake. But right now, we're getting, our score is increasing only when I click on the crab, not when I run into the cake. Also, we know that X and Y velocity are working, so we don't really need them anymore on our screen. I'm going to disable them from the view by clicking there. And also I'm realizing when I click the green flag, my crab, my player is just wherever I left that player at the end of the last game. So I want to add in some code that makes it so I start in a specific place every time, just so I can make sure that the player starts away from the cake so that there's actually some distance to travel. I'm going to go to, when the green flag is clicked, go to motion, grab the go to block. I want to make sure I've got the same XY position in my go to. So where is that crab? It's at minus 185, minus 145. And I'm going to drag that to when the green flag is clicked. And similarly with this cake, I'm going to give it a starting position also. Let's see, go to, and then where are you? You're at, oh, that's the same spot. So I'm going to drag the cake over to the right side again. That's 193, 136, 136. There we go. Now when I start the game, this is my starting screen pretty much every time. And I'm going to use the wait until block. I'm going to make this a really simple collecting game. Probably the simplest you can do. I'm going to grab this wait until block, and I'm going to grab in sensing. I want to sense another sprite. I want to sense when we're touching the player. So my cake, once the player touches it, I want it to disappear and for the player to earn points. So I'm going to take this when the sprite is clicked. We don't want the player to get points from clicking on the character anymore. That was a different game. So I'm going to get rid of that, but I am going to take this change score by 10 because I liked that, and I'm going to drag it onto my cake. And then I want to add one last thing. I want to make it so this disappears when we collect it. So let's see. That is a hide block I'm looking for. There we are. Let's give it a test. We can move around. I like the feel of this. It's pretty fun. I collect it. My score is up at 10, and it's gone. Amazing. Let's see. Don't have a lot of time. So that's a basic collecting. I do want to show really quickly, since there were some questions about broadcast blocks as being different from variables, how you can use a broadcast block then combined with what we've got already. Variables track stuff that need to be tracked all the time, but broadcast blocks are really for when you want to trigger events. For example, when the player starts a game, loses a game, uses life, changes levels, things like that are great opportunities for broadcast blocks. Or if you have two sprites that need to communicate with each other in some way, broadcast blocks can be really good ways to do that. We're going to use it. We're going to make a quick win screen because I've got a very simple game. There's only one of these cakes to to create. We could make more cakes. We could duplicate it and just have more cakes appear on our screen. Or I could turn this original cake, which actually I realize now it's gone forever. It's not reappearing, so I need to make it show at the beginning when we click the green flag now. I could turn this cake into a cake spawner that stamps out clones of cakes using the create clone of myself tool and the when I start as a clone tool. But right now, I just want to quickly put an end on this game. And maybe if there aren't questions or there are questions about this specifically, I can go into it. But I want to create a little win screen that'll pop up once you have got when this cake got to 10 points at the end of the game, and it's going to say you win. So I'm gonna actually paint a sprite here. I'm gonna select paint from the menu that appears, and I'm gonna grab some text, and I'm gonna say you win. I can change the color here. Actually, kind of like that. Purple color. Let's make it bigger by clicking on the arrow and then dragging up the corners here. And I can see in the stage on the right that my preview renders, so I can see exactly what this looks like. Oh, it's off center because for some reason this sprite is not at 0, 0. Let's make sure that it's at 0, 0. There we go. And then I also I need a background here. Let's make this like a nice celebratory green. And then let's also send it to the back. So I've got this big green circle, and I'm going to go to backwards here, and that's going to put it behind my text. Finally, I don't like this font. I had other font options. Where are they? Here they are. I like marker. So I'm going to really quickly give this code or this sprite a name. I'm going to call it windscreen. And I'm going to give it a when the green flag is clicked sprite. I'm going to tell it to show itself. Sorry, I'm going to tell it to hide itself when we start the game, because you don't win until the end of the game. And then I want to tell it to show and go to the front when we win the game. And when's that going to be? So I'm going to go to events. We're going to create a broadcast message that's going to be win game. So I go to broadcast, and these messages are just sort of repeatable commands that you can give from one sprite to another. So this is going to be called you win. And I want it to be when I receive you win, that the you win screen goes to the front and it shows itself. So it makes it so you can't miss it. Finally, we need to hook it up so that you win gets broadcast at the right time. Since we only have one cake right now, I'm just going to add it to the end here. I'm going to say at the once we've collected our last cake, our one and only cake, to broadcast you win. So let's see. Why isn't this working? Oh, I have show here when it should be hide. We found the bug. So I didn't hide my UN screen. There we go. I've hid the screen. I can go collect the cake. Now I am a full happy crab. And I'm going to do one last thing to this game. I'm just going to adjust the backdrop. I gave it a XY grid backdrop before, just because I wanted to be able to see the numbers I was working with, but I think underwater is appropriate for crab. And here we go. Well, it's a little hard to see the cake all the way over there, but there is our very simple collecting game. I do want to make sure that I reiterate that I got this from in the handouts folder of the drive that's connected to this office hour. There is a copy of this extensions PDF, and I started here at the score project, but there's a bunch of different projects here that have different, very simple game features that you could incorporate into your own games. Last thing I want to say is that there's a doc with some of the links from other example games that I've done with Velocity, and a link to the Scratch wiki pages for that and some more advanced things. And there's also a doc in here of some things that I think are really helpful game design touchstones, things to remember from the design perspective of creating a game that you always want to keep in mind, even if you're worried about just how to physically build something with code. The different parts of a game, some different ways that you can include a theme in your game, with the best way to include your theme always being to make it a part of gameplay, not to be something that's layered in on top, but something that's in every mechanic of your game. That each one of those connects to the theme, and to try to think about what is the sort of minimum game that you can produce, and try to keep your scope from creeping. That's always a common problem with developing games, is just wanting to add more things over time, and then all of a sudden your game gets bigger and bigger and bigger, and you don't have time for it. So it's always a struggle to keep your scope locked into a small, manageable thing that you can actually make. And then finally, to be iterative, try things out, experiment, get other people to test them. As much as possible, other people's feedback is always just the most valuable thing for designing games. And that is going to conclude my my game dev office hour here. I'll be happy to continue with questions, but I want to throw it back to Tanya.
Great. Okay, thank you, Alex. That was super helpful. So as a reminder, all of those documents that Alex was just referencing and running through are available in that Google Drive folder, which we shared a little bit earlier, and which my colleagues can reshare now. I'm going to go ahead and share my screen again and walk everyone through the process of entering your game into the competition. From your responses to the survey, it looks like everybody is approaching the finish line as far as their game creation process goes. So hopefully I can quickly show you how to enter your game in the competition once you're ready. So let me share my screen. Great. So you should be able to see my screen now. How to submit your game. Submitting your game to our competition can be completed in really 5 easy steps. It takes about 10 minutes to complete this process, and it's very straightforward. So don't be nervous about kind of jumping in and getting started on your own. The 5 steps are navigating to our competition website, creating an account, clicking My Submissions and Start a New Submission, responding to all of the questions in the form, and then clicking a button at the bottom of the form that says Save and Finalize. So I'm going to go kind of one by one very quickly through those steps. So step 1, navigate to the challenge website. The bit.ly link that's shared here is the challenge competition website, and it should look, the homepage should look like this image here on my slide. If you look at the left side of the screen, there is a section where you can either log in to an existing account, or where you can create a new account. And it offers a couple of kind of programs that are platforms that you can quickly link an account to, like Facebook and Google. You may or may not have those platforms. If you don't, there's a little kind of red link at the bottom that says create a new account. So I have an arrow pointing to that on my slide. So you're going to create an account and log into that account. You will need an email address, and you will need to share your first name. If you're working in a team, we allow students to compete in teams of 1 to 4. Only one person needs to go through this process of submitting the game to the competition. So once you are logged into your account, this is the screen that you will see. And there's this black box here that says start a new submission. And you're going to go ahead and press that start a new submission button, and that is going to pull up the submission form. The submission form has 3 parts. The top part, the first part, is submission contact information. So you're going to share your own contact information. And if you're under 18, you're also going to need to share contact information for an adult in your life. That could be a parent, that could be one of your teachers, an older sibling. It doesn't really matter who that adult is, as long as we are able to contact them if we need to. Part 2 is game team. So if you're working with some of your peers on this game, that's where you will enter information about who on your team participated in the game design process. Part 3 is kind of the meat of the submission form. That's where, for example, you will enter your game URL. And we will also ask you to respond to a couple of short answer questions about why you chose the topic you chose. We ask you to, or give you the opportunity to share additional materials if that's helpful for you. For example, if you've written something about the game, if you have some wireframes or some art you created for the game, you can upload additional materials to that section as well. The number one problem that we see with submission forms are students who have accidentally submitted the wrong link and the game URL leads to a broken link. And when this happens, we will reach out to you to give you the opportunity to fix that link and send us the correct link. Otherwise, we will not be able, if you do not respond to that email correcting the link, we will not be able to play and judge your game. So please double check that your game URL is correct. I can't stress that enough. I also have a PDF of the entire submission form that I've uploaded to the Google Drive folder, and I've linked to here in this bit.ly link. The PDF form is not meant to be a form that you complete in PDF form and then send to us by email. We need you to go through the process of submitting your game through our online platform, the process that I'm running through right now. The PDF is a view-only opportunity to see what questions we will ask and to kind of get ready to submit the final form. Step 5 is click Save and Finalize at the bottom of the form. There are actually, as you can see on my slide, there are 2 options at the bottom of the form. One says Save and the other says Save and Finalize. What Save means is that you want to save your progress. So you want to save the answers that you've already filled in, but you're not quite ready to submit your game to the competition, and you maybe want to come back at a later date and finish filling in the form. So that's what the Save button does. The Save and Finalize button could also be called Save and Submit, and that is the button that you press when you are ready to actually submit the form, and you will receive an email confirmation for us as soon as you hit Save and Finalize to let you know that we have received your form and that your game is officially in the competition. So those are the 5 steps. Hopefully that was clear, and I hope that that you're able to run through those steps on your own or with the help of your game making peers and or your teachers or parents. Games for Change is also available over the next week or so until our submission deadline, to help students with the submission process. So if you're struggling and you want some one-on-one help, you can reach out to us, and I'll provide my my email address on the final slide, and you can send us an email and say you need help, and we will either hop on the phone with you or set up a session so that we can get you through the submission process. So with that, I think the last, let's see what time it is. The last 20 minutes of this session will be kind of an open Q&A. And feel free to type your questions into the chat stream. We've also received some questions through that survey that you completed. So go for it. Please feel free to enter your questions, and Alex and I will do our best to respond.
So Tanya, I see there's this question from the original survey here about a timer that I'd be happy to answer quickly.
Great.
So let me go ahead and do that. Let me pull up Scratch. And I also want to let everyone know, if you do want to use if you want to remix the game that I just created, I just shared it and it is available on the slides. I just put the link on the first slide here. So if you see my my desktop, if you are able to access these slides, the link is right here. And there was a question also from the same student, I believe, about whether or not you can remix games that are on Mouse Create. The answer is absolutely. Please remix when you can. It's just always a good idea to use to save yourself time and use other people's code, because it'll also teach you how to use that code. But so really quickly, I want to show how to make a timer. And actually, I'm just going to do this in a new project really quickly. So I'm going to make a variable, and that variable is going to be time. And so let's start our cat at the start of our game when the green flag is clicked. Here, I'll full screen this. When the green flag is clicked, we want to set time to 10 seconds. We're going to put our 10 seconds on the clock. So set time to 10, and then forever, we want to wait a second and then reduce time by 1, right? If our unit of time is seconds, which it's probably going to be, we're going to tell this to wait for a second. Where is that? Wait 1 second at the top of control. And these wait blocks can be super crucial in Scratch for doing timing of any kind. If you want to make a countdown, if you want to time things out so that a certain animation plays at a certain time, wait blocks can be awesome. So we're going to wait 1 second, and then we're going to reduce time. Oops. It's going to be as simple as that. We're going to take time. Actually, no, let's change time by 1. By 1, I mean -1. So now I click the green flag. Why isn't this working? Is it because 1 second is too long of a time? That might be it. 1 second is actually kind of a long time. Interesting. Where's my bug here? We're showing time. Usually you just want to create a loop for time that increments your time variable by however much time has passed. Let's go. Set time to 10. Let's troubleshoot this. I'm not sure exactly why it's not working. Oh, it's because I didn't I didn't assign this to time. I have to select which variable I want Scratch to change. So that's probably the issue. Yeah, here we go. Now all of a sudden my clock is running super fast. but I can move that back. And then probably want something to happen when time equals 0. So let's go if, with our operators, that's how we're going to check whether or not something is greater than or less than something. So if time is less than 1, variables time, then we probably would want to end our game right there. So this is something that you might want to use a combination of variables and broadcast blocks. We could broadcast a message, end game. If time is less than 1, and then maybe when we receive end game, maybe a screen pops up that allows you to reset, and you use another broadcast block to set your time back to 10 and start running this loop again, or running a similar loop. Let's say you could reset a level. You can play with the timing here. But so now let's see if I can just, there's like a stop all. Here we go. So I just want to see when I receive endgame stop all. We're going to change this to our super fast clock again. There we go. Our time stops at 0. So this is a really simple fast timer, but by using broadcast blocks and checking the time with if statements, and some combination of those, you can make a system that will reset your time. Or you could potentially put a variable here for your starting time, so that different levels have different starting times. I'm not sure exactly how you're using this, but that's kind of the basic timer introduction. I should stop and see if there's more questions. I'm not sure how much of our time I've used on that one. Any other questions? Because I could show a little bit more on resetting game states, or I could also go into some wall collider fun stuff. But yeah, it's a great question. I actually need to get the chat stream up. I can't see it at the moment. Let's see, we just got a little time left. So let's see what's in the chat here. For parents helping their kids. Chat stream up. I can't see it at the moment. Sorry about that feedback. Yeah. So let me go back into that timer, and I'll go a little deeper into a player lose scenario. Actually, can do it in this one, my simple maze game. I go back to sharing my screen. So I think the key concept when it comes to creating a reset button or resetting your game, making sure that your game state always starts from the same place. The key concept for any kind of reset is that every single thing in your game that that is interactable, everything that can change, it needs to have some kind of starting initialization, some kind of you need to have some moment where your game puts all the pieces together. When you play a board game, usually you first assemble. If you're playing chess, you put all the pieces in the right order. If you're playing Monopoly, you got to get the money organized and get everyone tokens. And there's some sort of setup. And so as a video game, you're going to need to do that with your code in some way. And so once you have that setup script created, and it could be that each piece of each individual sprite that you have has a piece of code tied to it. So for example, in the example game I was making here with, oh, sorry, this is a different game that I was working on the other day, but I can show it. So this is a really similar game to the game that I created with you, where I can move around and collect stuff and my score increases. But this one, there's some walls that I can bounce off of. And so my player sprite here has some code that's my initialization code. So when the green flag is clicked, go to a certain position, set score to 0, set speed to my starting speed. Now, if I want to reset, actually, I can use my blocks. And this is a way that you can kind of save yourself from duplicating some code. So I'm going to create a block here that I'm going to call my reset, because I want reset to happen when I start the game, but I also want it to happen when someone loses the game, right? You want it to be as if they're starting from a blank screen. So I'm going to define my reset as everything that my character did when it started the game. And then I'm going to drag this little reset button over here. So now when the green flag is clicked, it's going to run reset. And now I can make it so, because I have reset defined as its own block, that if something else happens, I can send a broadcast message and I can just tell it, hey, run reset. And that's easy for me to remember. I don't, if I add more stuff to my game, I can always add the code for the reset right into my reset block. And that's been a really common bug for me when I work on my own personal projects, is as I add additional features to a game, it can be easy to forget to make sure that every component has a reset built into it. So for example, let's make it so right now I have this set so that I have these broadcast blocks around this block. I made this little thing of wall sensors. Let me show it. But I made just another sprite around my player here. I just duplicated the player, removed everything from it, and all the code, everything, and I just drew 4 different colored blocks around it. And I made it so each block has, I made it so it hides itself when it appears and then follows the player forever. Just always goes to the position of the player. And then whenever one of these blocks is touched, whenever it depending on the color and whenever it touches one of my obstacles here, which are all the same color, like these walls, it broadcasts to my player which bumper was collided with, and then my game applies velocity to bump it in the right direction. But just so to show an example of, for example, resetting, I'm going to make it so when I touch the right bumper on the wall, I'm just going to straight up lose the game and start over. Actually, let's make it the bottom bumper, because that'll be fun. I'm just going to add in here a broadcast. I'm just going to go to broadcast. If I bottom bump, I'm going to say, nope, not you win. That's the other one that I have. I need a new message, and I want to call it you lose. And what does you lose do? When I receive you lose, my code's getting a little messy here, but that's okay. When I receive you lose, I just want to reset. So let's try this. Now, here's my game. It's pretty normal. I was moving around, hitting obstacles, but if I touch the bottom, I start right where I started at the beginning. Now, right now I have my water here, this collectible. I have it randomly generating in places, and that's not resetting. So what I could do here is just go into events and add when I receive you lose, put in this whatever conditions that all these have. So And I can tell it to go to a specific place. Whatever code you add onto your sprite, you just want to make sure you always have the opposite of it, so that when you do want to reset, you're able to do that. And that's as brief of an explanation of resets as I could do. Great question, though. Let's see. Take a look at the chat. We out of time? No, we still have a few more minutes. Does if there aren't other questions, I can add one little thing, which is just hooking up a button to connect to your retry. So I think that's a pretty familiar concept for a lot of game players. Go back and Scratch. So if I wanted to make a button, and this is actually a really good best practice for anyone who is developing a game, which is probably all of you. If sometimes you want to make buttons that you can use as a game developer that your players don't necessarily use. For example, you may need to practice, or you may need to know what the end of your game looks like, and you don't want to have to always have to beat the, like, go through all the levels to be able to test the end of your game. And likewise, you might not want to have to go through the time of losing levels to test what happens when you lose. So we're going to create a button super fast here. I'm going to go to Paint, going to make a square, purple square here. You know what? Let's make it our big red button. And I'm going to make it a little smaller. Center it there. Actually, it doesn't need to be that big. I'm going to put some text on it, some text in black. I'm going to say reset. And I'm going to move this button here. So this is a button that I want to be able to use as the game developer to just be able to reset my game whenever I need to try it again because I'm testing a new feature. And this, very simply, you can just add a green flag, click, or sorry, when this sprite clicked, so we want this to be a button, so it'll sense if I click on the sprite, and now because we made a message, I can just tell this to broadcast, you lose. So whenever you're trying to synchronize something between multiple sprites, broadcast blocks can be a really great way to do that, especially when there's some kind of trigger or condition that is supposed to move your game from one state to another state. Variables are really good for keeping track of things that the computer needs to always be checking every second, like how fast is my sprite moving, or if you need to display something like score. But when you're trying to control the flow of your game from moving from one thing to another, broadcast blocks can be a great way to do that. So now if I click you lose, my character starts at the beginning like this. There we go. Well, we have just another minute. If there's a last question or any parting words, but I think that's all for me. I want to thank you for asking good questions and for being here.
Great. Yeah, thank you so much, Alex. That was super great. Thank you to everybody for tuning in. As a reminder, your games are due next week, April 29th, at the end of the day. So please don't hesitate to reach out to either Alex at Mouse or me at Games for Change. Our email addresses are right here on the screen. We are totally happy to help with any questions you may have between now and then. So thank you again, and we look forward to playing your games.
Yes.
Thanks, everybody.
Take care.